Okay. So this is where we left off. We went through the unit circle. We got all of the angles in degrees. We got all of our angles in radians. And now we've got all of the coordinate points around the unit circle. And then we looked at all 6 trig functions. So we are gonna kind of start where we left off here. We're gonna find all 6 trig functions of a specific angle. That's why it's always like sine of theta, cosine of theta. You always have to find some trig function of an angle. So on part C is where we left off yesterday. Part C is the angle negative pi thirds in radians. All right, so this is the first time we had a negative angle. We had to find our 6 trig functions of. So negative, was this negative pi thirds? So here's my radians. Here's my positive pi thirds, was like right here, my positive pi thirds. But they want a negative. So for my negative angle, I'm gonna go the same distance, but I'm gonna go in the negative direction here. Right here is my negative pi thirds. That lands right on this spot right here. Yeah.
Couldn't we just find like the positive, I guess the positive version of it?
So you could find this positive pi thirds, and then you would have to change one of the signs of your xy points. Do you remember?
Okay.
So you could do that if you want. Take the positive pi thirds, and then you would have to then basically change this y value. Goes from a positive y value down to a negative y value. You would have to adjust the sign of your y value.
You can also like multiply it by 2 pi to find the positive version of it.
So 2 pi is a full circle.
Yeah. So that you could. Yes.
So if you go a full circle, you're going to land in the same spot.
Add a full circle to it so you could get the cosine.
Oh, okay. Yeah, you could add 2 pi, which would, so your negative pi thirds plus 2 pi is going to end up with your 5 pi thirds. So that's what we actually had here, was the 5 pi thirds. So that works. Yeah, if you want to turn it into a positive angle, you could add a full circle, add your 2 pi, so not multiply, but add your 2 pi, and you can land in the same spot. Yeah, that works. So either way, I kind of know that I'm in at this spot, which I need the xy point that goes with it. So I'm going to go down to this circle down here. The xy point that goes with it right here is the 1/2 and then negative 3/2. All right, so again, my x is going to be with, I tried to color code that. My x is going to be with the cosine, and my y is going to be the sine. And then I'm going to keep using those for everything else. All right, so my y value was, let's see, in this particular point, y value is negative root 3 over 2. So my sine is the y value. Sine of negative pi thirds. I always have to have sine of an angle. And it was the y value, negative root 3 over 2. All right, and then cosine of my angle negative pi thirds is the x value, which the x value was the positive 1/2. So my cosine is positive 1/2. All right, and then tangent of negative pi thirds is going to be, it's kind of what I did here. You know how I try to color code that? I did like the green over the yellow. I did my sine over my cosine, or the y over the x, however you want to look at that. So I'm going to set it up the same way. It's messy. You got a fraction over another fraction. We're going to have to simplify this, but that's fine. Okay, but is everybody okay on the setup here? Why I did a messy negative root 3 over 2 and then divided by a 1/2? Yeah.
Wasn't the 3 over 2 the y in the negative 1/2, or the negative 1/2 the y in the 3 over 2 is that x?
Yeah, the root 3 over 2 was my y value, which the y value goes with sine. So negative root 3 over 2 went with my sine. Is that a little better? Yeah, you could treat tangent as the y value over the x value, but like the same thing, you got your sine from the y value, you got your cosine from the x. So it's pretty much, you can also say it's sine over cosine.
Okay.
Yeah, that works. All right, so we have it set up. We need to simplify though. Instead of dividing by this 1/2, I'm going to multiply by the reciprocal. So I'm going to multiply by 2 over 1. 2's divide out. And in fact, I've got negative root 3 over 1. That's great. That goes down to a negative root 3. And there's my simplified version for tangent. Okay. So I've got these main 3. By main 3, I mean I can now do the reciprocals of each of these 3 to get the other 3 trig functions. So my cosecant was the reciprocal of sine. So cosecant of negative pi thirds is, instead of a negative root 3 over 2, it's still a negative, but it's going to be a negative 2 over root 3. I did the reciprocal of it, which is not considered simplified. I do have to rationalize the denominator, like have no square root in the denominator. So I multiply by my fancy version of the number 1, a root 3 over root 3. So I get a plain 3 in the denominator. All right. No more square root in the denominator. That was the whole point. And the numerator, if I multiply these, I get a negative 2 times root 3. Messy, but that is actually considered more simplified than the negative 2 over root 3. All right, so cosecant was the reciprocal of sine. Secant is the reciprocal of cosine. And I have to have secant of some angle. I'm going to do secant of negative pi thirds is the reciprocal of cosine, which was a 1/2. So I will, instead of 1 over 2, I'm going to do a 2 over 1, or the whole number 2. There we go. And then cotangent. Cotangent is the reciprocal of tangent. I need cotangent of an angle. Cotangent of negative pi thirds is the reciprocal of, now I had a like negative root 3, you can put it over 1. If I do the reciprocal of that, I get a negative 1 over root 3. So I do have to rationalize the denominator here. I'll multiply by root 3 over root 3. And I get a negative root 3 over 3. A nice pretty whole number in the denominator now, so that's considered simplified. All right, so lots of fractions, lots of square roots. Any questions? We got no questions on this, for reals? You guys at home, how we doing? Thanks, Susie. All right, all right. Thanks, guys. Okay, so then let's move on. I'm going to look at, if we know the domain of the unit circle is between -1 and +1, which kind of makes sense. So I'm going to just draw this over to the side here. My unit circle. Domain has to do with x's, and my x's were kind of bouncing between, let's see, for cosine. My x's were bouncing between this -1 and +1. So that's why they had your domain is between -1 and +1. Well, your x's have to do with cosine. So this kind of means your cosine is bouncing between a -1 and +1. Cosine of whatever angle. It's going to go between -1 and +1. And then my sine, I keep putting the sine in green here, all of my y values, those are also bounced between -1 and +1 y values. So if the y value is my sine, this means my sine of whatever angle will be between a -1 and +1 as well. Okay, so if for some reason you say that your sine of whatever angle is 2 or 1 point something, anything greater than 1, you know it's a little off. If you got like a -1.5 or something, it's a little off. It should be between -1 and +1. All right, so then 5 and 6, it says sine of 2 pi is a full circle. Oh, sorry, not sine. Since 2 pi is a full circle, You're going to do sine of t plus 2 pi n equals sine of t. So, okay, let me clarify what this is even talking about. Sine of some angle, and you're going to add 2 pi is a full circle, right? And it's 2 pi times n, like some n number of full circles. So if like my n was a 1, it's like I went 1 additional full circle. If my n was a 2, I had 2 of the full circles that I go around. But they're saying that that's just going to equal just sine of t, like without that. Because I can go as many full circles as I want, I'm going to land in the same spot every time. That's how circles are, right? So same thing for cosine. If I go 2 pi around that circle there, I can go 2 pi once, I can go 2 pi twice, 3 times, some n number of times, and I'll still end up with cosine of t, the regular cosine of t. All right, so my point on that is this guy right here, sine of 420 degrees. I'm going to treat that like it is sine of something. I'm in degrees, so I'm not going to do 2 pi, which is like a full circle in radians. I'm going to do a full circle in degrees. So I'm going to say like 360 degrees. So like 360 plus what is 420? 60. All right, which means that this is going to be the same as whatever sine of 60 degrees is. All right, so 60 degrees up here. There's our pi 6. 60 degrees was right here, and my sine is always the y value. So my y value or my sine at 60 degrees was √3/2. All right. So let's look at number 6 here. It is in radians now. In fact, it's negative in radians. So I think this, well, this n right here, it could be a negative number. Like I could have subtracted a 2 pi, but it still is a full circle, just in the opposite direction. Which means I'm going to treat this like, see, I've been doing my cosines in yellow here. So I'm going to treat this like it's a cosine of probably something minus 2 pi. Which it looks like this is in terms of thirds. It's -7/3. I think I'm going to write my 2 pi. I'll do it in terms of thirds here. So like 6/3 pi. Are you okay with that? All right. So what's can I subtract 6/3 from and I get 7/3? Ooh, -1/3. Nice, -1/3. So I got like a -1 pi thirds right here. Okay, so that's saying really I don't need to do this extra 2 pi. I could just say it's cosine of -pi thirds. I can actually do it again if I want to, if I wanted to go around the circle again. Yeah, Dylan, what's up?
Well, what is the n for? 2 pi n.
2 pi times n. I did only one of them. That was like a 1 in this case. I did one of the 2 pi's. I could do 2 of the 2 pi's, right? Two 2 pi's would be 4 pi. What was that?
So n is just the number of pi's.
Yeah, n is the number of 2 pi's. Yeah, like the number of full circles that you're going around. Nice. So if you already know what the cosine of -pi thirds is, great. But if you want the cosine of a positive, you could do this again. Or in fact, you could, if I'm going to do what you were talking about, Dylan, I could treat this as 2 full circles. Like 2 of the 2 pi's is 4 pi, right? So I could treat, instead of a -6, I can do like a -12/3. That's like a 4 pi, right? So if I change that, I got to change this guy then. What can I subtract 12 from and get a -7? 5? A positive 5, right? So if I put a positive 5 pi thirds like this, I should still land in the same spot on my unit circle. This would be a positive now though, because I don't really have to go that 2 full circles. I'm just going to leave it as a 5 pi thirds. Okay, So I don't know which one's easier for you, the 5 pi thirds or the negative pi thirds, but they both land in the same spot. So I'm gonna go back up to our circle in radians here. So yeah, if I had negative pi thirds, zoom out here. So instead of my positive pi thirds, I had a negative pi thirds, that would land right here. Or if I had the positive 5 pi thirds, this is, you can actually see it right here, positive 5 pi thirds lands in the same spot. So either way, that's where we're at. And they wanted what, cosine of it, right? Cosine of that, which if you want to look at the XY point, there, my cosine is always the X value, which the X value there was 1/2. Okay. Any questions on this? You guys at home, how are we doing? Thanks, Sadie. Everybody else? Oh, I heard from one person at home. Should I be nervous about this? Oh, come on. Zach, Sky, 80, Shara, how we doing? I heard from 80.
Good.
Okay, so Nicole, we got a 1/2 because of where 5 pi over 3 is located on the circle. Yes, exactly. So 5 pi thirds was right here on my unit circle. And we wanted the cosine of it. So we wanted like the X value at that particular angle, which, so I'm looking at my X values right here. At that particular angle, my X value was a 1/2. All right, cosine is always the X value. All righty. So let's look at even and odd functions then. So your even functions, yeah, no problem. Your even functions are ones that if you take the cosine of some negative or secant of some negative angle, it's going to be the same as if it was a positive of the same angle. So like if it was a cosine of negative pi thirds, that'll be the same thing as cosine of positive pi thirds. Now, keep in mind, cosine has to do with x's, right? And your secant is the reciprocal of your cosine. It's like 1 over your x. So pretty much all the stuff that has to do with x's, those are even functions. Your sine, cosecant, tangent, cotangent, these guys had to do with y's. Your sine was a y. Its reciprocal cosecant, 1 over y. Tangent was y over x. Cotangent, x over y. All these guys have a y in them. And for that reason, these are odd functions, which means that if you do the negative angle here, so if I had like negative pi thirds, it would be a negative in front of my sine of positive pi thirds. Okay. All right, so we haven't really looked at actual examples yet. Let's see if we can apply that to actual examples. Number 7 here. If cosine of negative t is 0.3, so it's cosine, it's this guy over here. Cosine of negative t is a 0.3. Then cosine of positive t, those are equal to each other. That would be the exact same thing, a 0.3. All right, secant. Let's see here. Where's my secant? Secant is another even function. Oh, apparently I didn't give you guys an odd function, sorry. But secant's another even function. They said secant of t, so I'm kind of starting on the right side of the equation this time. Secant of t is a -2, but if I go to the secant of negative t, those guys are, again, totally equal to each other. I just get -2. But yeah, I gave you guys both even functions. So the reason those are the exact same thing, if I show you this on the unit circle, let's see what it looks like. So I'll look at number 7 here, the cosine of some negative angle that is 0.3. So All right, so I'm gonna do a cosine of negative angle in that I'm gonna go in the negative direction here. Cosine of that negative angle is, yeah, they said a positive 0.3, so I should have a positive x value. The cosines are my x values. So say I go to, I don't know, maybe I go like right here or something. It's like not one of the ones that they gave me. Maybe it's like right there, but the x value is a 0.3, right? So if that's a cosine of that negative angle, I'll put negative theta there. If I go the same distance, but in the positive direction, so if I go to my positive theta, those guys have the same x value. So my x value, they said that cosine was a 0.3. So then the other x value also has to be a 0.3. So Jack, does that make a little sense at all? Yeah, we're all right with that. Okay. Alrighty, so those are both even functions. Let's look at, I'm gonna add another one on here. Let's do an odd function. All right, so Alina, pick an odd function. I don't care which one. Pick one. Which one? Sine? Okay. So we'll add one on here for sine. What if I do sine of negative t? If that equals, I don't know, give me some messy decimal. I don't really care what it is. So actually pick some messy decimal between -1 and 1. I don't really care what it is. Just give me some number between -1 and 1. What was it? 0.35, is that what you said? All right, cool. All right, so if I have my sine of negative t is this 0.35, then I'm gonna look at this odd function thing right here. Sine of a negative angle then is negative sine of t. Okay, so what this means is I'm gonna get a negative sine of t is, oops, right here, negative sine t, there you go. Then your negative sine of t should be the same thing. It should be a 0.35. Okay, so if my negative sine of t is a 0.35, what is my positive sine of t? Nice, yeah. It's like I changed the sign on both sides, so I get a negative 0.35. So I don't know, like on your homework, whichever one they're asking you about, we should be able to answer either way. I was using this odd function for sine. Okay, questions on the even or odd functions? All right with those? All right, we're good. So I think this is our last bit for today, actually. So it says we will use calculators only for angles that are not on the unit circle. So like these guys up here that we were looking at on our unit circle, if it's not one of those lines that we have on there, I'll show you guys. So if it's not like pi fourths right there, if it's something between pi fourths and pi sixths, if it's like this angle right here, it's not on my unit circle, I have to use a calculator. But we do expect that you use the unit circle, not a calculator, for these specific angles that we have on here. All right, so these guys are not on there. 5 pi 7s. I don't have a 5 pi 7s on there. So I'm going to open my calculator. I don't know which ones you guys have. Whatever calculator you're going to use on your homework or on the test or whatever, go ahead and bust that out. Let's make sure you know how to use it for this trig stuff. Okay, so for this calculator, I have, if I go to the mode here, The third thing I have is radians and degrees. There's a mode of radians and a mode of degrees. Scientific calculators do the same. You have to check and see if your calculator is going to do the sine of some number of angles in degrees, or if it's going to do the sine of some number of angles in radians. Mine currently is in radians. Check yours out. You guys
How do you get to that menu?
What was that?
How do you get to that menu? I have a TA84 as well.
Click mode.
Oh, okay.
Yeah, I went under mode right here. Mode. All right, who has scientific calculators? What do you guys have to do for the scientific calculators?
There's a button called DRG.
Oh, DRG, like degrees and radians.
And then
and-
on that, there's 3 options: degree, radian, and then there's something called DRG. And I'm not sure what that is.
Okay, but on your scientific, it said DRG. Is that
Yeah,
what?
it's at like the very top next to the second button.
At the top of it, next to the second button. Okay, awesome.
Well, mine's a DEG, RAD, and GRAD.
Okay, yours specific. Okay, nice. So you guys online, they said some of them specifically say DEG, DEG. Some of them said RED, RAD, and then what was the other one?
GRAD.
Oh, GRAD. Okay, but it's so it has like 3-letter like abbreviation for what mode you're putting it in.
I'm guessing RAD is,
The radians for rad. Okay, so I'm gonna go second quit. Mine's in radians, which I wanted radians for this. I wanted sine of, and I have a sine button here. I wanted sine of the 5 pi sevenths. Now, do not put a 3.14 in for the pi. 3.14 is rounded. I want 5, and then I'm gonna use this pi button here over 7. So I didn't round my pi or anything. Okay, and here's what we got. On your homework, please pay attention to what they want you to round to, and I don't round until the very end. So once I put this all in my calculator, I didn't round my pi to 3.14 or anything. At the very end though, if they say to round to the nearest hundredth or thousandth or whatever it is, let's go to the nearest hundredth. That's 2 decimals, so 0.78 in this case. Did you guys get 0.78? Everybody got that on their calculator? Okay. Nicole, yes, that's my goal. All right, so what about this cosecant of 2.0? Is that like 2 degrees or 2 radians?
Radian,
How'd you know if it's radians?
there's no degree sign.
Oh, there is no degree sign. It's got to be radians. Okay. So also I've got a sine button right here. I've got a cosine button, and I've got a tangent button. I don't see a cosecant button. All right, so here's what I've got to do. Ooh, no, I'm not going to use the inverse button. I'm going to write it as a fraction. 1 divided by, it's the reciprocal of, cosecant is the reciprocal of sine. So I'm going to do 1 divided by sine of my 2 radians. The mode in my calculator is radians.
my calculator has a little green thing above the COS.
Uh-huh.
COS, the power of -1.
We are not doing that one to the power of -1. I'll talk to you about that in a sec. I'm doing 1 divided by sine of 2. Or 2.0, something like that. All right, so there is my, if I round to the nearest hundredth, it would be like 1.1. If I did that,
I get syntax error.
did you do this though? Sine of the -1 exponent?
I did the 1 divided by.
You're on rad.
Yeah, we should be in radians.
I am on that.
Okay, I'll look at that in a sec here. I'm going to show you, a lot of people were looking at this sine of -1, which you guys know what exponents do. You guys are smart. Like a negative exponent does a reciprocal, right? Except for this is a bit confusing. It's not an exponent. It's a notation for a sine inverse function. It's giving you a totally different function.
Yeah, I figured it out. It was,
Okay.
I had it set in class.
Okay, hang on. So if I did this sine inverse, I'm going to show you, I wouldn't get the same thing. Ooh, error, domain. There's a problem here. These are not the same thing. It's not raising it to a power of -1. It really looks like it. It's just a notation for an inverse function. which I think you guys have seen inverse functions like this before. We did like f with a -1. It looked like that was my f inverse. That was my inverse function. So that's what they're doing on sine or cosine or tangent. They're putting a little -1 on it because it's the inverse function. Cosecant is not the inverse of sine. It is the reciprocal of sine. Like you flip that fraction here. So again, if I'm going to the nearest hundredth, I would go with 1.1, or you can put 1.10, something like that. Okay, any calculator questions? Yeah. I did not hear that question. What was that? Oh, it's how to find. Google it. Yeah, we might have to do that. I'm not sure. We'll look at it. All right, you guys at home, how are we doing with these calculators?
Good.
Doing good. All right, all right. Okay, I'm going to